Hello friends, this video on chemical bonding part 9 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 8. Let's talk about the formal charge. In many cases, if you see, the net molecule is not having charge. Sometimes they have charge also, but sometimes it is possible to assign charge to particular atom. Please note, I'm assigning charge to particular atom. Sometimes the whole molecule may be positive, maybe neutral also, but or may have charge, but it's possible to assign formal charge to each atom. Please note, I'm talking about formal charge to each atom. And this formal charge in each atom in the polyatomic molecule, of course, is nothing but the difference between the number of valence electron of the atom in the free state and the number of electrons assigned to the atom in the Lewis structure. We'll explain to you with an example. It is nothing but the number of valence. For example, oxygen, right? It has 6 valence electron. So this is the natural form of oxygen atom. It has 6 valence electron. But in some Lewis structure, let's suppose you are assigning 7 electrons to this one particular oxygen, then it will have 6 minus 7 as minus 1 charge. Or if you are assigning only 5 electrons to this oxygen, then it will have plus 1 charge. I'll take one example. This is nothing but the natural state, how many electrons it should have, that particular atom, minus the number of electrons assigned to the atom in the Lewis structure. Generally it is same, that's why there is no formal charge on the atoms in most of the case, but in some case they do have some formal charge. The formula is pretty simple. It is nothing but the number of electrons in the free state for the atom minus total number of non-bonding electrons and 1 by 2 of total number of bonding electrons, because the bonding electron is shared between 2, so it is half of the bonding electrons. The example is O3. We'll take the example. Let's draw the structure of O3 molecule. So oxygen has 6 valence electron each, so it will have 6 into 3, 18 valence electron total. 18 valence electron to start. Let's draw an oxygen and let's draw with 2 bonds. Correct. So for 2 bonds we consume how many electrons? 4 electrons for 2 bonds. So we are left with 14 electrons. Correct. So let's make this guy happy, the central one. So this guy has 4 electrons now. Let's add 4 more. So 4 you add in this, that is oxygen 2, let's suppose. I'll make it oxygen 1, 2, and 3. So we have 10 electrons now. Let's make this guy happy, oxygen 1. So it has 2 electrons, so we have to add 6 more electrons in this. So it will have 4 electrons remaining. So with 4 electrons we can't make this guy happy because this needs 6 electrons, right? So this structure is not possible. So with this electrons, oxygen will say, don't be sad, we'll share 1 more electron. So in that case, they'll come up with a new structure where there will be a double bond here and single bond here, right? So let's start things from scratch once again. So we start with 18 valence electron. We use 6 electrons for 3 bonds. So we have 12 electrons. Let's make the central atom happy. Central has 6 now. It needs 2. So minus 2 we have. This is for oxygen 2. The central one is oxygen 2. Let's make the oxygen 1 happy. It had 4. So it needs 4 more. So we have 6 remaining now. Let's make this guy happy, oxygen 3. It has 2 electrons now. It needs 6 electrons to be happy. So this guy is also happy and we have 0 electrons, right? And everybody is happy. And this is the structure. But please note here that in this case, all these atoms are not neutral. Let's see this atom now. Let's name this atom 1, 2 and 3. So let's see atom 1. Atom 1, for charge of this atom, charge of atom 1 is nothing but 6 is the valence electron for a free state oxygen, so we'll have 6 minus How many electrons this guy has? This guy has, I think, 4. I have not drawn, sorry for that. This guy has 6. Let me draw this also. Minus 4 because it has 4 lone pair electrons. Minus. It has how many shared pair? Shared pair it has 8, right? But out of the 8, sorry, 4. Shared pair it has 4. If you see this and this, out of 4 it has only half of that, which is owned by this oxygen. Right? Hope you understand this. So it will have net charge of 6 minus 4 minus 2, that is 0. So there will be 0 charge on this oxygen one. Why? Because 6 is the number of valence electrons, the free oxygen. 4 is the lone electron it has now. And 4 by 2 is the electron it has from the shared pair. So let's talk about charge on oxygen number 2. 6 is again the number of valence electron oxygen has in free state, minus 2 electrons it has, right? Minus 1, 2, 3, 4. If you see here, 4 it has shared, so 4 by 2, because 4 electrons are shared, but out of that the contribution will be only by 2. So this becomes 6 minus 2 minus 2, that is plus. Sorry, there's a mistake here. So it has 6 shared electron here, right? 6, 2 plus 1, 3. And total contribution will be 6 by 2, that is 6 minus 2 minus 2, that is plus 1. So it has got plus 1 charge. So this guy has got plus 1 charge. So let's talk about charge for oxygen third. 6 is the electron in the valence free state of oxygen. Minus 1, 2, 3, 4, 5, 6 lone pair it has. Minus 2 it has got from the shared. So but the contribution it will have is half only. So this becomes 6 minus 1, that is minus 1. So this atom has 0 charge, this guy has plus 1 charge, and this guy has minus 1 charge. Overall charge is neutral, but atoms has the formal charge. Hope you understand this. So if you are confused with this 4 by 2 and all, just count the number of bonds. So in this case for O1 there were 2 bonds, so use 2 here. For O2 there were 3 bonds, so use 3 here. For O3 there were 1 bond, so use 1 here. Because 1 bond is nothing but 2 electrons, so we are just saying 2 by 2, that's also 1. So we just count the number of bonds if you are comfortable with that, right? Number of electrons in the free state 6 minus number of electrons here minus number of bonds. So this is the case. Also here I'll tell you that, which I'll not discuss much, this structure I could have drawn in this fashion also, right, where my oxygen 1, 2 and 3 is this way, where oxygen 1 and 2 is single bond and 2 and 3 is double bond, right? So both the structure are possible. So in such case where we have multiple structure possible for a Lewis structure, we have the term of resonance. We say that the resonance exists in this case, and with that makes the molecule all the more stable. We'll discuss more on resonance after a few slides. So I'll not I'll not discuss this much now. Just understand the formal charge here. So how to get the formal charge? For oxygen 1 we had, for all this oxygen this is constant because this is something which is natural for oxygen. The first oxygen, this was the 4 because it has 4 electrons here, and by 2 because it has 2 bond here. The second oxygen 6 is natural, 2 is here because it has 2 electron here, and 3 is there because it has 3 bonds here. For oxygen 3 also 6 is natural. This 6 comes because it has 6 electrons, and this 1 comes because it has 1 bond. So the question comes to your mind is, we read about the formal charge in the atoms for a particular nucleus, for the molecules. But overall the molecule may be neutral also. So what is the advantage of understanding the formal charge? What is the need of understanding the formal charge? So we told that the molecule can be neutral also. So it doesn't make much difference in understanding the charge. But the critical reason why we understand the formal charge is because it helps in selection of lowest energy structure. And I told that everybody wants to be stable with lowest energy because energy is something like stress, right? So the lowest energy structure is one which has the lowest formal charge on the atoms. So if I have one structure where I have, let's suppose 3 atoms has got -2 or +2 charge, the other structure, possible structure where there is no charge or -1 charge. In that case, the lowest one which is possible is chosen as the correct structure for the level structure. Correct? Because, hope you understand, because we have seen scenarios where we get the multiple structure. So you have, if you get the multiple structure or multiple level structure, the one with the lowest charge is my best structure. Correct? Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.